Hello guys, welcome back. In this video, we will be solving second problem of Leetcode weekly contest 386. The problem says 3047, find the largest area of square inside two rectangles. Okay, pause the video, read the question and then we will move forward. Cool. So what the question says there are n rectangles in a 2D plane, and it's just basically that will be given two arrays. One will be containing the bottom left coordinate of a rectangle, and another will be containing the top right coordinate of the same rectangle at ith position. Okay, now so basically we'll be given two arrays containing this bottom left and top right coordinate. Similarly for this rectangle also we'll have this 2 as bottom coordinate and top left, sorry, top right as this coordinate. Similarly for this triangle third one, we have 3 1 as bottom left coordinates and top right coordinate as 6 6. Okay, now what the question says we can select intersection of two given rectangles and we need to find out the largest area of square that can fit inside this selection. Okay, now seeing the example, if we'll see like the first rectangle, though it looks like square, it is square here, but let's talk in the terms of rectangle only. So if we'll see the first rectangle and the second rectangle, there's an intersection of this part. If we'll see here, this coordinate is 2 2, so let me draw it. So one of the rectangle is 1 1 and 3 3. So let's mark it as 1 1, and here it is 3 3. Another rectangle is 2 2 and 4 4. So let me draw another rectangle, and this coordinate will be 2 2 and this coordinate is 4 4, and one more rectangle is 3 1 and 6 6. But use this one. So that rectangle is something like this one. Sorry, not this one, but here, something like this one. This will be 3 1 and this will be 6 6. Now there is one area which is overlapping. If we'll consider this triangle, this, let's say this is triangle 1, this is triangle 2 and this is triangle 3. So there is this area which is getting overlapped, or intersection of these two triangle, first and second. And if you'll see this coordinate, one of the coordinates is 2 2 and the top coordinate is 3 3. That's what the intersection area is, right? So you'll see this is nothing but a square of side 1, so its area will become 1. Now, there is one more area we can see intersecting over here. Okay, so see this one also here. So if you'll see or check out, the coordinate of this will be nothing but, see, the x coordinate at this point is 3 and the y coordinate at this point is 2. So this coordinate will be 3 and 2. Now talking about the upper coordinate we know this is 4 4. So we have another rectangle, remember it, 3 1, sorry, 3 2 and 4 4. But we know that we have to only consider square area. Like in the question it is mentioned that we have to find the largest area of square that can fit inside. So to make it a square, either we can make it something like this one, if it is 3 3, or here we can make it 4 3, something like this one. So either this square we can consider or this square we can consider. Okay, we cannot consider this rectangular area. Okay, I hope till here we have clear. So one more thing or important point to note down. So if we have given one rectangle, right? So how can we determine which a rectangle or what kind of square, or like what will be the side of the square? That's very simple. So we have two coordinates. One is here and another one is here. So if we'll check for the side, this will be one side length and this will be another side length. So whatever minimum side length we have, we can form a square of that particular side length. Correct? Listen carefully what I'm saying. We have two coordinates, bottom left and top right. What we'll do, we will see, let's consider that this is a rectangle. Okay, then we will calculate the side length. Side length will be nothing but the difference of y coordinates. Okay, that is, let's say, length a, and the difference of x coordinate is length b. We know that for a square a must be equal to b And now since A is greater than B over here, then we must take B, and we should make it such that, or like we should consider that much portion of A only, such that that is equal to B. So what can we do? We can simply take minimum of A and B, minimum of A and B, because A is already greater, so that means it will be fulfilling our condition of considering a square of size B. But we cannot do the same, because if we'll consider square of side A, then it must be something like this one. But we know that it is not possible, or it is not intersecting area. So that's why we are taking minimum of A and B. Okay. I hope till here everything is clear. Now, how can we decide? How can we decide which is the intersecting part? Which is the intersecting part? So, for that, let's consider few rectangles. So this is first rectangle, and second rectangle. It can be something here. Okay. So in that case, this is the intersecting part. Let's say one rectangle is here, and another rectangle is here. Then there is no intersecting part. Now, there can be one scenario such that one rectangle is here, and another rectangle is something like this. Okay. There are many other possibilities that one rectangle is here or one rectangle is here, but let's just focus on combination of two rectangles. So what will happen? It will happen. So if we'll look carefully, if we consider just two rectangles, this one and this one. So what we can say that the square we are forming, or the intersecting area we have, not a square, the intersecting area we have can have, see, we have two bottom left coordinates, that is one is here and another one is here. Similarly, we have two bottom right, sorry, top right coordinates, one is here, one is here. So the common intersecting area is nothing but maximum of bottom left coordinates and minimum of top right coordinates. Okay. Okay. So if we are considering two rectangles having an intersecting area, then what can we say? That the bottom left coordinate of that intersecting area will be nothing but the maximum of bottom left of bottom left of both the rectangles, and similarly the top right will be the minimum of top right of both the rectangles. For example, let's say in this example only, considering this triangle first and second. So as we discussed, this is 1 and 1, and this is, so considering these two rectangles, what we have one as 1 and 1, 2 and sorry, it was 3 and 3, and another one was something like this one, 2 and 2, and 4 and 4. So if we'll see over here, the common area we have has coordinate what? This 2 2 and 3 3. And if we look carefully, we have two bottom left coordinates, that is 1 1 and 2 2. So our bottom left is 2 2, because in bottom left we have to consider the maximum bottom left. Similarly, for the top right, we are considering the minimum, that is 3 3. So there can be scenarios like, let's say here it was something like, or wait, let's go at that point later. So here I think it must be clear that what we'll do, we'll take the maximum of bottom left or minimum of top left. So that will be the common reason. Now there is possibility something like this one, something like this one. So let's say that this rectangle 1 has coordinate something like 1 1, and here it was something like let's say 5 6, and there is very tiny. Okay. So here it will be something like here it will be something, let's say coordinate difference is 1, so it will be something 6 and 6, and here it will be, let's say 7 and 8. Okay, now in this scenario, if we'll look at the minimum, or if we'll try to find the intersecting area using the same method which we are talking about, that look at the minimum of bottom. So if we'll look at the minimum of the bottom left, so what we'll get? 1 1 and sorry, maximum of bottom left, so it will be 1 1 and 6 6, so it will become 6 6 as bottom left, and for top right we have 5 6 and 7 8, so taking minimum of those will become 5 6. So in this scenario we'll have to see that if our bottom left any coordinate of bottom left is becoming greater than any coordinate of matlab corresponding coordinate. So like if we're talking about x, we will see x. If we're talking about y coordinate, we will see y coordinate. So if the bottom left coordinate is greater than its corresponding top right coordinate, that means it is simply not possible. It is simply not possible. Okay. Now similarly, if we see over here, we can automatically see that this will be the considered rectangle. Considered rectangle. And now once we have our desired rectangle, we can calculate the sides by simply subtracting the y coordinates and x coordinates, and whatever the minimum side value we have, we can directly consider or say that that particular side square can be formed. Okay, I hope this would be very very clear to you. So this was the only concept, or this was the only concept you needed to understand in this particular question. So okay, let's now go to the code ones. So see, what I did was, first of all, we initialize answer to 0, calculated the number of rectangles. Now, one more thing, that we should not consider the same rectangle. Now, see, whenever we are trying to consider two rectangles, we should not do that. I mean, there is only one rectangle of this size, and we are considering this itself. So we should not do that. So that's why when we have to consider two rectangles, I am running two loop, but I am only considering them if I is not equal to j. Because see, if I will be equal to j, then in that scenario, what will happen? That particular rectangle will be selected, but that is not true, right? Because in answer we should have two rectangles with intersecting area. Here that particular rectangle is intersecting with itself, but we cannot consider that. That's why I am skipping them. Now now first now as discussed, we are taking out the minimum of top left coordinates, top right coordinates, similarly minimum maximum of bottom left coordinates, and we are checking if bottom x is less than equal to top x and bottom y is less than equal to top y. Then what will be the side value? Side will be the minimum of the x side, or the difference between the x coordinated, or difference between the y coordinate. So whatever the minimum of them will have side as that, and the current area of that particular intersection square will be nothing but the side square. Okay, now we will maximize our answer, and finally we will return our answer. Okay, let's try submit this. Okay, so this is an AC solution. So I hope this would be very much clear to you, but if you guys have any doubt, let me know in the comment section. Okay, thank you guys, see you in the next video.